Okay, so today I want to go over your homework assignment from yesterday. I thought the first problem I assigned was pretty similar to the problem I had given you or gone over yesterday. So we'll start with that one. In this problem, we see that there's some function f of x squeezed between two polynomials. One's a line and one is a parabola. And then we're asked to find the limit as x approaches -1 of that function that's squeezed between the other two. So the first thing we're going to do is look at the limit as x approaches -1 of the lower function. This is a simple direct substitution. So we've got -4 over here. And then we're going to look at the limit from the upper function, which is a parabola, x squared plus 3x minus 2. When we substitute in for that, it's also a direct substitution. We've got 1 minus 3 minus 2, which happens to be -4. Since f of x is squeezed between two functions that are going to the same value, we can say, therefore, by squeeze theorem, the limit as x approaches -1 of f of x is going to equal -4. And so that was very similar to the one from page 39, problem A. But the final problem I thought was really tricky, and I was impressed by how many students were able to figure this out on their own. The first thing that we look at when we look at the squeeze theorem is where the function is going. And so this function is going to infinity. And so we need to find a function that would trap this cosine function. The difference with this one is that we have a 3 here. So while we know that cosine is locked between 1 and -1, once it becomes negative, we have to switch those bounds and add 3 to each term. So we have 4 is greater than or equal to 3 minus cosine of x is less than 2. Or if you want to write it the opposite way, it depends on how you prefer these things. Either one of those would be acceptable. From there, we look at the original function, and we see that where we're trapped between is a 1 over x plus 2. And so when we squeeze this function, we're going to have 4 over x plus 2 is less than or equal to 3 minus cosine of x all over x plus 2 is greater than or equal to 2 over x plus 2. And again, if you decide to switch the bounds the other way, that's fine as well. Okay, and so now we're going to evaluate the limit of the upper function and the lower function. And so what we will see here is the limit as x approaches infinity of 4 over x plus 2. Now, when we approach infinity, what we're really talking about is end behavior. And so the end behavior for both the upper and the lower is going to be the same because the numerator degree is is less than the denominator degree. And so these are rational functions. We're going to approach 0 on both sides. Therefore, by squeeze theorem, the limit as x approaches infinity of 3 minus cosine of x over x plus 2 equals 0. Now, I think if I were just teaching this outside of the realm of squeeze theorem, I would encourage my students to look at the function. So if we go back up here, what I want you guys to identify right away is that limits at infinity or to infinity is just asking for end behavior. And like I talked about in the first video, when we look at that, we look for the dominant function. And the dominant function here is 1 over x plus 2. Cosine is not going to dominate. Trig functions do not dominate any other function. They're actually the lowest on the realm. So I know the end behavior 1 over x plus 2 means that it's going to 0 based on that whole, the degree of the numerator is less than the degree of the denominator fact. So this isn't, to me, typically something I would do via squeeze theorem, but it certainly can be proven that way, as you see here. All right, let me know if you have any questions.